Right, now what I'm going to show you is some things that have cropped up actually in the last week when I've been observing, and they've made me stop and think, what the hell is that? And the first one, actually, Rod's kind of alluded to it. This was the moon phase of a couple of nights ago. It's not one of my pictures. I've just taken this from the web. And actually, it shows up here. There's a little dark spot just there. And it's quite a way away from the...
Shall I ask if the moon is made of cheese?
Uh,
And I'll put them over the edge.
so but anyway, I was looking through a telescope and I noticed this dark mark there. And because of where it was, so far away from the terminator, and it was really dark, at first I just thought it was a bit of rubbish on the eyepiece or something, but a little bit of fiddling and that, and no, it was there. So I actually took a few pictures earlier in the evening, but this was just testing out the camera. And when I processed them later, this one shows dirt on the sensor, so there's quite filthy actually there and there, but there's almost a hint of what I was seeing visually just there. And the blow up, it's just, they could just about see it with this horrible sensor dirt as well. And I was really intrigued. I mean, yeah, it must be a shadow of some sort, but it's a long, long way from the sunrise. And I was quite puzzled by it. I took a picture with a camera phone, and I couldn't really get it to focus, but you might be able to make out there it's slightly dark. Visually, it was really obvious, really dark, in contrast to what's around it, which was very bright. And I was puzzled by this, but anyway, I went and looked online, same as Rob did, and it's this thing here. There is a tall mountain, and it is tall enough that actually it casts a shadow when the terminator is way off out of this picture here. So actually, yes, that's certainly what I was seeing. I've not noticed it before, but of course, each time you look at the moon, say it's the same phase, the lighting is never the same twice. The angles are never quite the same, and it could be that, well, maybe there's optimum angles and things. But here's another picture I clipped off the web, and there you can see the shadow, not quite as big. It's not quite in the same direction. And here's another picture where you can't see it at all. The shadow's gone. And maybe the angles are just wrong. Although the sun quite low, you can see in the crater here that it must be, the terminator must be not too far out of shot, but nonetheless it's not there. So it may well be that it's just a combination of angles and things. Sometimes it shows up more than others, but it really, at the time, it's really striking. And of course, at first you kind of think, oh, is that something new? Has something happened there? Well, no, but anyway, I learned something, and it was interesting to follow it up. Although it wasn't, as I might have hoped for, an alien spaceship or anything like that. But you never know. So further on, now I also saw, actually a few nights before, something odd to do with satellites that really was a puzzle. Now, as soon as we mentioned satellites, many of us now sort of get rather depressed because of all these SpaceX Starlinks that are zooming across the sky. I think I read today that there were over 1,000 of the damn things up there already. I think there's meant to be 12,000 at the end. It's rather depressing. In fact, also depressing was the news yesterday that a launcher had gone up carrying 148 satellites, although most of them, well, all of the satellites are rather small, little tiny shoebox size things. It's getting awfully busy up there. And with these cheaper rockets and that, it's becoming more and more accessible. So, well, gloomy. But it's not that kind of satellite that I was concerned about. What I was noticing was probably something to do with orbits much higher up. So here's I don't know what language that is, but anyway, this is a diagram of an orbit here. This is a geostationary orbit, this one here. And anything in that orbit goes around the Earth, in 24 hours, the same rate at which the Earth is rotating. So any object should stay above the same point on Earth throughout that time. So that's why it's called geostationary. Now it's a long way out. It's 22,000 miles. Most of the stuff we're seeing, the low orbit stuff, is around what, 300-400 miles maybe. So this is 500 times further out, maybe more. And it also takes a lot of energy to get there. So it's a long way out. It's a big investment to stick a satellite out there. So if you do have these satellites, they do show up sometimes. If you point a camera at the celestial equator, which is where these satellites are going to be, and turn the tracking off, so just a camera on a tripod pointed at the right place in the sky, the stars will move as the Earth rotates, but the satellites, these geostationary ones, stay put, and you can then make them out as little dots, and they're strung out here in a sort of ribbon. They're not in a perfectly straight line, because some of them are slightly above or below the orbital plane. I'll come to in a minute. But that's one way of spotting them with a camera. Or here you can turn the tracking on, and of course the stars now become points because your camera is following them. But that means that the geostationary satellites will leave tracks. Now here, there's a bunch of them. I got this off the web. The reason they cross over is certainly because the satellites are not perfectly on the celestial equator. They'll be slightly above or below, so they will appear to go up and down a bit, and that's why they're not parallel. But anyway, that's another way of showing them up. Now, I've been wanting to try this for some time, but the weather never cooperates, or when it does, there's a bright moon in the right or wrong place. So, well, I'll get around to it sometime. But this isn't the only kind of satellite that's possible. Now, this is not the best of diagrams. The geostationary orbit that we just talked about is here, the purple one. It's above the Earth's equator. It's geostationary because from the Earth you appear to stay still. But there is a bigger class of orbits which is called geosynchronous. And all that means is that you go around the Earth in 24 hours, but not necessarily above the equator. So if you like, geostationary is a subset of geosynchronous. But anyway, if you are, say, on this pink orbit, over the course of a day, well, from the ground track, you might look like one of these down here. Depending on this inclination angle, you might be like that. You might turn out a big circle across quite a large hemisphere, or a tilted one like this. All sorts of ground tracks are possible, depending on just how much you've tilted here. Now, if you want to keep an eye on a whole ocean, this one here, the blue one, might be what you want, rather than just staying put over the equator. So they are used. Anyway, now, if you are in geostationary orbit, there's always a slight problem because it's valuable real estate out there, and if you keep bunging up satellites, well, there's a fair amount of room there, but ultimately satellites wear out and then they're just junk, and you don't want to collide with them. So by convention, the satellites usually, after they're finished with, they should have enough fuel on board to push themselves out just another 300 kilometers into this graveyard orbit here, where they're out of the way. You don't put a satellite there unless it's defunct. So that's a sort of dumping ground, provided your satellite can do it and hasn't just worn itself out and is incapable, which often happens. Now, what does happen with the geostationary satellites is, this isn't the best of drawings actually. If you took this green line of green dots here, this is the celestial equator, this is the geosynchronous sorry, the geostationary orbits, and that's where you'll be. But the sun is actually pulling at them all the time, and it will try and pull them down into the plane of the Earth's orbit, which is the ecliptic. And of course, that's tilted with respect to the equator, and it's 23 degrees. I mean, it's the angle of the Earth's tilt, and the sun is tugging at them all the time. Now, in order to keep your satellite on station, you need little booster rockets on it, little motors, which every so often will correct it and keep it there. And again, if that goes wrong, then your satellite will drift out gradually into effectively a geosynchronous orbit, and one that's at level with the ecliptic. So it'll be tilted there. And that happens to them. Now, I don't know what this picture that I found, I'm not sure what all these green ones are, but whether some of these are defunct or not. But anyway, satellites they end up drifting out of the geostationary orbit and going into a more tilted one. That's just the nature of the gravity from the sun. Now, there is, here's an idea of it. So there's your geostationary orbit there above the equator, but the sun is trying to pull you into this orbit instead. So if you want to stay put, you need to expend a bit of energy to do so. And when you can't do that anymore, well, your satellite's going to wind up here. Or if you moved out to the graveyard orbit, yes, that orbit, but 300 kilometers further out. So that's the way it works. Now, what did I see the other night that was so puzzling? Well, I was sweeping with a pair of binoculars, as a very good binoculars, around Orion, and I was looking around this region here, and just there's Orion's belt there, and around here, a bit below Orion's belt, more or less in the direction it's sort of pointing in, I saw a flash. Just the star appeared to flash, not fairly slowly, and I noticed it and thought, oh, what's that? And I kept looking, because normally we'd expect, well, if that's a satellite in orbit, then the next flash will be further on, but that didn't happen. And in fact, 15 seconds later, the flash recurred in much the same place. And then 15 seconds later, it occurred again, but I think it was more or less the same place. And I was watching this for quite a while, and it was quite real. And it was roughly a 15-second interval. And I would say it was about magnitude, I don't know, 4 perhaps. Easy with the binoculars, but with the naked eye, I don't know, not with my eyes anyway. And I was puzzled, what the hell could this be? So I nipped indoors because I thought, well, it could be geostationary. And I wanted just to check where the celestial equator was. You know, the line which is the equator, if you like, projected up into space. Well, it's this line here across the middle. But I was seeing something down here, which is about 7 degrees away. So it wasn't really in the right place. Now, could it be a satellite drifting off that's lost its sort of ability to stay in geostationary orbit? Well, the ecliptic is up here to the north, so it ought to be drifting that way. So it could just be a stray satellite. The flashing would be the satellite rotating, probably with a shiny bit coming into view every few seconds or so, and it might be 2 panels on sides, so it's a sort of 30-second rotation. Now, this was about 11 o'clock at night, so the sun would be behind me, more or less, and that's kind of optimum for a reflection. The light source behind me and the reflection coming straight back. But I wondered, it still struck me as odd that this flashing light, not a low orbit satellite, clearly a satellite of some sort, but where was it? And then I came across, I looked a bit further. Yeah, it was just there. Now, it may have moved slightly while I was watching. I couldn't be absolutely certain, but not by very much if it did. And when I came outside again, having checked the coordinates, clouds had come over, as they do, and I didn't get a chance to keep watching. And the next night, well, it was too cloudy, and the next night there was too much moon, and I never really got the chance to repeat it. But anyway, what could be going on? Well, I came across something where somebody mentioned another kind of orbit, which is used a lot. Now, normally, if you've got a geostationary satellite like this is fine for things like satellite TV and so forth, provided it's reasonably high in the sky for you. So if you're in the sort of middle part of the Earth, even here, even in Britain, yeah, it's accessible. But if you're up near the poles, well, it's really near the horizon, and it's a line of sight thing, and well, trees and goodness knows, all sorts will stop it. And really, geostationary is not great if you're at high latitudes. And the Russians have this problem because large parts of Russia, large parts of Siberia, are pretty northerly and not really amenable, or not really great reception for a geostationary signal, a signal from a geostationary satellite. So they use a different solution. Now it's this, which I found. I'm not sure how this is pronounced. Molniya. Anyway, it's a particular kind of orbit. This is named after a particular class of Russian spacecraft, and they started using it. And it's a highly elliptical orbit, like this. And the thing with orbital velocities, and it's Kepler's third law, or whatever Kepler's laws, the closer you are to the thing you're orbiting around, the faster you go. So low orbits are fast, and high orbits are slow. But if you're in an orbit like this, well, when you're close to the Earth here, you're going quite quick. So look, 11:01. Well, this is a 2-hour trip around the Earth. But when you're out here, you slow down. Well, 2 hours is a much less distance. And you can tune these orbits to, well, they go out almost as far as geostationary satellites do, but you can get the orbit to be 12 hours quite easily. And that means that every second orbit when you get out here, you're above the same bit of the Earth that you were, well, last orbit but one. And so it can serve as a kind of a communications or a satellite or something, especially if you use more than one satellite. So if you have several on this orbit or orbits like it, you can get more or less continual coverage with something high up in the sky from northern latitudes. And so this is what the Russians do. And you can have all sorts of orbits. You can tilt them in any way you want. Obviously, the Russians are interested in being up north, but there are all sorts of variations. Now, the Russians, say, do this for military and for communications satellites. The Americans have been doing it as well with their military satellites, and you never quite know what they're up to. You never find out. But again, it'll be to look downwards for the most part. Now, the ground track for these satellites can look like this. So here we go. This is looking up. Here your satellite comes there, and then it spends quite a bit of time over the United States. So this is when it's far out from its orbit, and it comes back in nice and quick, and then slowly over this bit, which it may or may not be interested in, and then the next time round, oh, it's back here again. And of course, if you had several satellites staggered along here, you would get more or less complete coverage of here if you were interested, or there. And that's the essential of the idea. Now, this kind of orbit is used. It's been used a lot with interplanetary probes. So from Mars, for example, you arrive in Martian orbit, and I'm not sure which one did this, but this very wide elliptical thing, the same kind of orbit, and use a bit of aero braking here with the solar panels to slowly circularize the orbit, very, very slowly, without putting too much pressure on the panels, as I seem to remember. And I think the same thing is done. I think the Venus Express probe is in an orbit something like this, where it's close up and then far out. It suits communications, and so it's very tunable because you've got the parameters you can change to look at different parts of the planet. So it's very common. Now, could this? Well, let's go back. Could this have been what I saw? Well, I think it easily could be, because it's not really restricted to the celestial equator, and yeah, you could easily be going south on the descending part of the orbit. So it could well be that. I could well be seeing either a Russian satellite or maybe an American military satellite, but that's my bet, that it's that kind of orbit. So if you see a flashing light or something that doesn't appear to move much over the space of 10 minutes or so, but isn't on the celestial equator and isn't going towards the ecliptic, then I think it's probably going to be one of these. So there we are. I didn't know that at all. Now, just to remind you, in orbit, if it's in low orbit, this is the space station, which I caught just the other night. The space station is unusually large, of course, and chances are you can image it with, well, with the equipment I've got, really basic, but people can get much better with this with equipment that's quite a bit better, but not ridiculous. But as I say, the space station is very large, but you can, if you're lucky, and if the seeing is good enough, you can pick up other things. Now, this here is one I took some, oh, don't know when it was now, a couple of years. This is a satellite from a video frame, and it's an American military satellite, according to the data I could get. And it seems to be this one, which other people have managed to image, although mine doesn't quite look like that. It's the equivalent of the Hubble Space Telescope, but pointing downwards. I mean, it really is astonishingly powerful, but again, it's classified, but it gives you some idea of the size. So probably that would be the main tube, and there's a dish there and some sort of aerials and things sticking out there. I'm not sure how it relates to these, or even if it's quite the same one. It's unusual to be able to do this, but if you get very good seeing, you can do it. This is a 6-inch telescope doing it. This is another one. This is a Russian satellite a few years ago. I think it's one of these. I think those are panels, solar panels, and then there's a bit of bodywork. I can't be absolutely certain. It may only be there are 3 panels rather than 4. Again, it's classified, you don't really know, but no, it's getting there. And this one, which I was rather proud of, this is a Russian satellite, and it's this is the official drawing of it. And my frame looked like this, and I think, yes, if these two are here at these panels, this bit here might be this might be some kind of lid that's opened up, exposing, you know, telescopes and things. That's what I suspect anyway. But there we are. Anyway, the point I wanted to make with these things is these kind of let's just go there. This sort of thing, you can do this if it's in low orbit and if you're lucky. But these things that are further out, they're only ever going to be traces on a, you know, either dots or trails. They're far too far away to see anything else of. So anyway, satellites, the very word doesn't have to mean Starlink misery. It can be a bit more interesting than that, but I don't know for how long. Well, anyway, thank you for listening, and I'll stop sharing now because I think that's it. There we go. There we are.
Thanks very much, John.
Could I point out one thing which seems to have escaped? If you want to look at a geostationary satellite, which is in the plane of the equator, you wouldn't be looking at 0 degrees.
Yeah, there's a bit of parallax, but it's not going to be huge.
About 5 degrees.
5? Oh,
It's quite big.
well,
You just do the sums.
yeah, no, I hadn't. I thought it was less than that. All right. Well, the thing I saw was at 7, so it's not actually out of the. It's not out
We
of the.
certainly have to look south by, a declination about minus, I would have thought 5, 6 or 7. I was just doing a quick sum and I haven't done it accurately.
Well, there you go. I wonder about that. I mean, when I can get a camera set up and actually trace these things, all I've got to do is see where the dots are. And of course, the chances of me getting a clear night when there's no moon are not great, are they? So.
But if you look at it, we're roughly, well, not quite 4,000 kilometers above the equator, going north, much a bit less than that. So the satellite is 35,000 kilometers, and a triangle 4 one side and 35 the other is an angle of there about 4 or 5 degrees. So you'd certainly have to look quite a long way south of the celestial equator to see any geostationary.
Yeah. Oh, there you go. I mean, it's still curious though that. I say when I first saw the flashing light, I immediately thought, "Oh, it's an aircraft." No, because it didn't move, and again, you want it to be something more exciting, but it's not going to be.
Yeah, well, that was actually, I reckon, about the same, about the right distance below the celestial equator.
I did look on the charts. It was 7 degrees, but
yeah, sounds about right to me.
Pretty close, yeah. But I mean, I say to actually catch one flashing. Oh, I've never heard of. I mean, I did a Google search, and 1 or 2 people have said they've seen flashing stars in Orion, but not very often. It seems to be unusual. But you've got to be looking in the first place. If you're peering through a telescope at something in particular, you're never going to see these things. And if you're sweeping with binoculars, well, it's just going to be luck. Now, I was using initially my I've got these very wide angle, these magnified by 2, but they're like little opera glasses, and you can see I think it's about 18 degrees, and I first noticed it with those because the angle was so big I could pick them up. But had I been using more powerful binoculars, I probably would have missed it.
I think the point that I was making is that if you want to try and photograph any of these things, do not point the telescope at the celestial equator.
Well,
do a sum first to work out how far south you have to point it.
Yeah, well, I will be using such a wide angle that I wouldn't have to worry about that.
Oh no, I realise that, but yeah.
The Pentax I use has this self-tracking capability, and it means that I can set up in about 30 seconds, really quick. I had plans for the pandemic that I could just put it in the back of the car, drive off wherever I felt like it, stop anywhere in the countryside, pitch it up for in seconds, stay there for half an hour, and then go off to the next place, because the setting up was so quick. But of course, with all the restrictions and things, it's never seemed like a good idea since then. But it'll keep.
What Pentax have you got?
I've got the K70.
And if your dad's still got his, your dad had a pen.
I've still got mine.
Well, the modern Pentaxes have this ability to track that, to move the sensor so that it tracks the stars. some of them have got a built-in GPS. Mine hasn't. I had to buy a little module that goes on the top. But that's the trick. So you don't need an equatorial mount. Just a Pentax.
I seem to remember hearing somewhere that Pentaxes, I don't know whether it's modern ones or old ones, are quite good at registering hydrogen alpha.
I think the old ones were. I'm not so sure. I mean, the pictures I've taken are much the same as what you've got with your Canon. I mean, you can just about pick out the horse head, which I can just about pick out as well, but only just in my skies. Yes.
Well, thanks very much, folks. I think